Hello, everybody. How are we? Oh my gosh. You know, I have to say, I wish you could see how beautiful you look from this stage. Oh my goodness, it's incredible. The diversity in the room, I can feel the attitude that wants to learn and participate in this amazing community. And I'm honored to be here today to share in that. My connection was lost. This is exactly what I was afraid of, but let's see if we can restart things here. Technical difficulties. I would tell you a dad joke to fill the time, but as usual, I can't think of one. There we go. All right, so as I was so lovingly introduced, my name is Tejas. That's pronounced like contagious in the English language, which, for those of you who aren't familiar with the Indian name, that's a quick mnemonic for you, and it is not Tejas. I get that so much here. And understandably for Texas and things, but no, it is Tejas. And I work at a company called Contiamo in Germany. I actually flew 14 hours across the world to be here and share in the joy that is the React community with you today. Thank you. At Contiamo, we have used React for years, and we love it. We also use GraphQL, and it's just an amazing family of libraries and JavaScript-based tools that we use and enjoy. But I have to say the greatest joy at my work is this. I work alongside some of the most brilliant people I've ever met in my life, and it is just an honor to be with them. We laugh, we cry, we get on each other's nerves sometimes, but you know, it's like that everywhere, right? But unfortunately, that's not what we're here to talk about today. We are here to talk about REST. And not just REST, but REST and GraphQL. And stuff. And I spent a lot of time thinking about how to structure this talk in a way that's engaging and in a way that can impart some of the knowledge that we've kind of amassed over the years of working with React and GraphQL. And I think the best way to do that is to tell you a story. And this story is one where it's based on real-world use cases that we've had and things we've heard in the community. And like any great story, it starts with JavaScript. We love JavaScript, we use JavaScript, and we're thankful for JavaScript. Now, we have built a product that was built entirely in JavaScript. This was before even the React days. This was back in Backbone. And it was a really great product. We loved it, our customers loved it. It was useful and helpful. And for many years, that was how that was the product we built. Over time, though, what ended up happening was our product, we kind of lost confidence in the ability to refactor it. We were afraid to delete parts of it. We were afraid to rename things that we exported because, heaven forbid, we run into, cannot read property, something of undefined, right? Or we couldn't afford to see NANs anywhere because we were like a data science company. We still are. And so numbers are important. And eventually, over time, our JavaScript got old. We ended up having a lot of legacy, and we wanted to refactor the legacy, but for the reasons I just mentioned, we couldn't. Effectively, we were feature frozen against our will, And so we decided, much like many people here I've spoken to actually, we decided to let's just rewrite things. Let's rewrite things with scalability at its core. Let's rewrite things to last. And that's what we did, and we did using TypeScript. Now, there's mixed feelings in the room about TypeScript, I'm sure. And I'm looking at some of you, and I understand. It's new syntax, right? Your reasons are valid. There's new concepts, there's generics and unions and intersections, and should we have to deal with these things? Some would say yes, some would say no, but for us, the benefits were actually immediately visible. We could confidently refactor, we could confidently delete, and things felt really good. One concrete use case where TypeScript helped us was we had a design system. And if you want to do something well, it's your design system, because it really underlies everything in your UI, right? It's your buttons, your cards, your icons. And so you want the APIs to be as transparent as possible. You want the documentation to always be up to date. Heaven forbid there's a prop in there, and it does nothing, right? We use a tool called React Style Guidist for our documentation. And this is actually developed by my good friend Api Parser in Berlin. And it is amazing, because what it does is it takes a markdown file as input, it will parse the markdown file, and output a living style guide. Like, it will render your React components. If you have JSX code snippets in there, it will actually like eval the code and give you like the components and the interactive code playground underneath, which is a text area. And if you change the text, your rendered components change. So it's a really interactive thing. In fact, I'd like to show that to you right now. So if we switch over here, this is what our documentation looked like. We have just a whole suite of components, and all of this was generated just from the README. So if we look at button, for example, we have some text, a title, and this. This is literally just generated from the source code. So if I go to source here and go to button, what you see here, this markdown file, it's rendered here. It's the same file. And so our documentation comes to life. We can further explore by playing. So I could go button color. Let me just make that a little bit bigger. Color is red. And if we zoom out, we see, yes, it's red. And I can, in real time, update this. And it updates. So it's this living thing. The problem is if our documentation is out of date, for example, if I say prop that doesn't exist, if this was from my documentation, I have no idea that it's broken, right? This is just kind of, it's kind of a lie, really, to people consuming this library. Now with TypeScript, we can help this. What we ended up doing was, we took the underlying editor from Visual Studio Code, the Monaco editor. We put it in the browser and used it in place of this text area. We also fed it our type declarations from our compiled JavaScript from TypeScript, and the end result is this. This is the same source code from the same README, and if we go look at a button, it's exactly the same, but I click on this view code thing here, and I get a rich text editor. It still admittedly looks the same, but look at this. It says press Alt space inside a component for available props and documentation. OK, let's try. And here, I get a list of the props available to me to use. What's more than that, I can say color, and I can give it like a red, and it updates. But here's the cool thing. If I say invalid prop, it actually signals to me, wait a second, that doesn't exist. Your documentation may not be up to date. And this is one concrete way we're able to discover our own documentation library and keep it up to date. This has added huge value to us where I work. Now, I'd like to get into the technical details of this and show you more about how we did that, but we don't have the time for that because this is about REST and GraphQL. There is another talk I did at React Finland earlier this year that is a bit of a deep dive into that, and I'd recommend looking at that. But the point I'm trying to make is that TypeScript has helped. And we adopted TypeScript, and we used TypeScript, and our app was really, really robust. We haven't seen a runtime exception in a very long time, except at the network layer. So we would have this app, almost no runtime exceptions, but every now and again, Sentry would send us, uh-oh, something broke. And what ended up breaking was the responses to data we would get. So sometimes we would expect like an array, and instead we would get an object with like numeric keys. Other times things would just be null. Sometimes things would, like there would be breaking changes to the API that we didn't know about, and our app would effectively blow up. This, of course, led to a lot of bugs, and quite frankly, that made us really sad. Because as UI developers, we want to make it nice. We want to not have bugs, right? I think that's a fair wish. And so it's worth noting here that at this time, we were using RESTful APIs. In fact, we still are. We have valid reasons to use them. We just want to integrate with some other systems that work better in a RESTful architecture, and that's fine. But for our use case here with the UI, unfortunately, REST is just not very good. But you see, we're engineers. We don't just say these things. We don't just say it's not good, done, right? We qualify what we say. And for that, I will use a word that I wish we use more, and a word I'd encourage using. It's just not good because it's not a formal specification. Like, it's just a convention. There is no document that you can visit and say, this is what it looks like when a RESTful API is implemented. Which then leads to a lot of guessing games, right? Across both ends of the stack, front end and back end, client and server. For example, you send off a request to create a resource, and it was created. Now, does the server respond to you with a 200 status code because it's OK, everything's fine? or with a 201 status code because something was created. Well, I guess. No, we don't guess. How about this one? If you try to access something you don't have permission, does the server respond with a 401 because you're not authorized, or a 403 because it's forbidden, or just a 404 because you shouldn't even know it exists? I don't know. And so it leads to these guessing games, which ultimately culminate in meaningless discussion. Like, I genuinely want to be positive about this, but some discussions we have as engineers, especially when DX does not facilitate good UX, I would say are kind of meaningless. What do I mean by that? Well, I think if you're making an app for real humans with real problems you're trying to solve, I don't think any of them stay up at night thinking, what status code did that request use? Right? Like if you make a medical app, I don't think your users in hospitals are thinking about if it's a post, put, or patch. Right? We create apps for humans that are meant to give them value instead of discussing status codes and methods. And lastly, REST just has no contractual agreements kind of intrinsically built into it. There's things like Swagger and attempts to create these contracts from which you can implement backend and frontend, but there isn't something formal. Ultimately, I think it's best summed up with this. Now, I did not say this yesterday, but I did say this at some point when I made the slide. And this isn't like doctored or anything. This is an actual screenshot from an actual conversation that I had. And I think, this is ultimately my response to this. It's just like, are you serious right now? We have products to ship. And so, thankfully, while REST can be not so good, there's work being done in the space. And there are other paradigms for client-server communication that genuinely help. I would say GraphQL is one of those. I see Lee sitting right there. Thank you. GraphQL is very good. And again, we don't just make these statements without qualifying them. GraphQL is very good because exactly the opposite of those other reasons REST wasn't. It is a formal specification. It is, like, people have defined GraphQL as a lot of things informally, but if it is anything, it is not merely a query language. It is like a specification that you can look at and say, this is how the API is to be implemented. And I think that is an absolute game changer for client-server communication. You know what that does? You know what that does, React Conf? That removes guessing games. You're no longer guessing, should that be a 4.3 put? No, it's in the specification. And if you have some edge case where you actually have to guess things, it's an open specification, meaning once you have a decision, you could contribute it back to the spec, and nobody else around the world has to guess. And that means you can create the products that you love and you care about really, really fast. This then leads to meaningful discussions. What do I mean by meaningful discussions? Instead of discussing status codes and what content type this request should be, we discuss, can we cache this? Can we lazy load that? Can we defer? Like, we talk about things that directly impact our users and as a result create pleasant experiences that make the web altogether better. And lastly, GraphQL is built around a schema definition, right? And so there is a strong contract front and center from where you can implement your backend and your UI. These are just the developer experiences that I'm talking about with GraphQL. They're just the niceties of the DX. If I was to talk about the UX benefits, we would have to go off the screen and then some. GraphQL, in my experience and in our collective experience, has just been a godsend, and we're extremely thankful for it. All that to say, GraphQL is very good. But I spend a lot of time at a lot of conferences, talking to a lot of people, and I was once at, I think it was a GraphQL conference, and there was a talk, an entire talk dedicated to how do you convince your boss to adopt GraphQL. I was surprised that this needed to be a talk, but okay. And from the talk, I got the impression that a lot of people have a hard time adopting GraphQL. It seemed to me like this is a conversation that was had quite a bit. Hi, we want to add GraphQL services to our stack. Well, we can't because, stuff. And then we look at the because, right? And this is, again, this is gathered from various sources of hearsay. We don't trust JavaScript for an API. It's JavaScript, it's It's single-threaded. You know, it's like you have this like clock that follows the cursor around. That's what you do with JavaScript, right? You don't do an API. Come on, you don't do an API. We already have an API team, and they have tasks. I mean, just open Jira. Look in Jira. Oh, what's that? Jira doesn't work? Oh, I'm sorry. No, just believe me. They have tasks. We just don't have the time for that, right? Next quarter, we'll do a funding round, and we will focus on GraphQL, I promise. But like right now, you know, it's tight. Really, we just need to ship. We need to ship, ship, ship. But when you ship like this, you're working against the current because GraphQL actually can increase your velocity. And at some point, I've seen people react this way, you know, to these conversations. And other times, maybe your entire team reacts this way. Well, what can we do about that? I got to thinking. And I was like, well, I mean, I had an idea for a side project. I have used GraphQL for a while. I think it's clear now how I feel about GraphQL. And you know, I love the Apollo client and server and engine specifically. Like if you're here and you work on Apollo, I would just give you like a round of applause for it, because Apollo is Apollo team. Apollo is just an amazing suite of software, client, server, engine. It makes the developer experience around GraphQL so comfortable that then leads to nicer UX. And so heavily inspired by Apollo, I wanted to bring these benefits to REST. But could it be done? I think it could. And so I created a library called Restful React. Now, this isn't some variation of React or anything. It's just that naming things is hard, right? It's just a library that fetches stuff with RESTful APIs in a more comfortable way, at least to me. And I'd love to show that to you right now. So let's go over here. And this is just a little React app that I built. Nothing fancy. It's just one component that says, hello, React Conf. Very creative. And what we'll do is we'll use this library. And it all starts with importing something called a RESTful provider. So I will do this. Import RESTful provider from Restful React. And what this will do is it will give a little bit of context to the app. I'm then just going to, just like if you've worked with Apollo, it's kind of similar. I'll just wrap the app with this thing here. And this is implemented fully in TypeScript. So it's immediately going to tell me, hey, I need a base prop. And base is the host, the HTTP root of your requests. So let's talk to one of my favorite APIs in the entire internet, the dog API. And so this is going to change absolutely nothing in our app. But then we're going to go into app here and fetch data using Restful React. Restful React exposes hooks. It's a hooks-based library. And so I will const destructure something. And I'll use the useGet hook from Restful React. Okay? And useGet needs one thing. It needs a path. Where am I getting stuff from? And so I'll do / breeds image random. I want a picture of a random dog, because dogs make me feel happy. And in the destructure, well, what do I get? I want, and because it's TypeScript, I have this, autocomplete. I want to handle error cases for sure. I want to handle loading states, and I want my data. And so what I'll do is just relay that to the user. So if I have an error, I will h1. Oops, that's not a React component. I'll h1 and error.message. And if I'm loading, same thing. I won't use a spinner in this case. I'll just go ahead and say I'm loading. And then lastly, if I have data, I will img. Always remember your alt tags. And I will data.message. And everything should be fine. So now if I save this, what we're going to see is an image of a beautiful specimen, and more and more and more. Now, there's a problem with this, though, where the app would break down at the network layer, because I kind of just guessed this is what I'm getting back from the API, but I could instead expect, I don't know, a massage, you know? And then, well, now my app broke. That's bad. Restful React allows you to describe the shape of what you expect from the backend using generic. So I say I expect something that's a string, and now it immediately knows, okay, well, there is no massage. The massage is a lie. And because of that, I get autocompletion, and my app is resilient. And anything I do cannot really break that. And so this will fail at build time. So this will never actually make it to the user as well. So we've solved that, but can we do better? See, if you remember earlier, a few slides, we said REST is just not very good because of all of these reasons, right? That last one is kind of debatable. There are strong contracts in some cases. They're just in the source code of your backend API. At Contiamo, our backend APIs are implemented in Go, and Go is, it's typed. So my coworker, Fabien, he's genius. Like, his brain is, Anyway, he created a thing that reads the Go API implementation, extracts the type declarations, and then transpiles them to TypeScript. And now this is done with a whole bunch of regular expressions. It is incredible. And it works, and it's fully unit tested, and it's great. But we wanted something that would scale a little bit better. And so we started looking into OpenAPI, which, if those of you who haven't heard of it, it's an evolution of Swagger, a way to document RESTful APIs. And we had an idea, well, maybe we can use this. You see, they're meant to be human readable because they're JSON or YAML file. And so, that's why those formats exist, is because they can be read by humans. Except if you thoroughly describe a RESTful API, you have to describe stuff for get, post, put, patch, 200, 201, 404, it gets long. In fact, this is what it looks like in our code base. And this isn't even the full thing. So human readable, sure. But we want to use it. How can we use it? So what we ended up doing was we found, npm install OpenAPI parser. Right? There was a thing. So we parse this document, we extract it, and we look at schema definitions for backend responses. We then take those schema definitions and write them to a api.ts file. And then we have, because of this, we actually have transpiled from an OpenAPI document end-to-end type safety. But as Tom mentioned before, we care about DX, but also UX. And the reason we did this was because when the developer experience is good, usually the UX tends to follow. And I'd love to demo that for you right now. Let's go back here to our good boy. And what we'll see is, I'm just going to generate stuff from an API specification document. I will open the terminal. And Restful React is also a CLI that will do it for us. So we'll say yarn, Restful React, import. The cool thing about this code generator is you don't really need access to this OpenAPI file on your file system. It can fetch from GitHub. You literally give it your username, a repo, a branch, and a file path, and tell it where to put the final file. And eventually, it will do that. So you just run the command, and it goes to GitHub, fetches the thing, returns undefined because it's open source. We need to fix that. You're welcome to contribute, actually. Anyway, so it's done. We have ready-to-use things. And if we look at it, let's take a look at what that looks like. So now I have a new file, this green thing here, api.tsx. And if I open it, look at that. It's just the Giphy or Jiffy API completely described here. Now, I don't even need to look at this, because it doesn't concern me. But let's build a thing using this that can get data with end-to-end type safety from the Jiffy or Giphy, which one, whatever, from the API. To do that, we'll go swap out our RESTful base. Here, we're no longer talking to this delightful API, but we're talking to api.giphy.com/v1. And if I save, we'll immediately see, uh-oh, there's a 404. Understandable, because Giphy doesn't have this route, which is fine. So we're going to remove the useGet here. We're also going to remove this, and we will check this out. This is what makes me so happy. I'll just import something from my API that I just generated, and I will use the autocompletion to see what's available to me. Now, because of the rules of hooks, we know that they start with what word? Use. So let's use. And these hooks here are hooks that will get me data from Giphy, just for free. So let's try it. I have use random GIF, okay? I'm just going to pop that in here, use random GIF. And it doesn't really seem to need any parameters. Yeah, it's just an empty object. And look, I'm still able to keep the error and the loading, but data has changed. Look, message is no longer a thing. It's aware of what Giphy is going to send me. This is amazing. So instead of data, I will just use autocompletion. Data dot, OK, well, there's another data. Let's maybe alias this to like GIF response, just so we don't confuse ourselves. OK? But you can see that this doesn't go in the SRC, because it's not a string. It's something else. Dot. And then all of this from the Giphy API, just here, statically. How cool is that? I want images dot. Notice how this question mark just appears? That's because TypeScript has something called optional chaining. If it doesn't exist, it will just polyfill that to an empty object, and you can't read property this of undefined. So let's go to, I don't know, I want the original size, and I want its URL. And at this point, it is a string, so this constraint is satisfied. And if I save that, I will have, uh-oh, what's wrong? Well, I have an API key that I need to pass. Now, you probably shouldn't do this. Just like share your API key at a conference. I'll revoke it after, so that's fine. You also probably shouldn't, you shouldn't put it on every request, because I just opened my network dev tools and I see your query param with the API key. So maybe a little bit more thought here, Giphy. But I will pass query params, and I'll pass an API key of this. Pretend you've seen nothing. Oh, you saw nothing. And I save, and bam, we have a random end-to-end type safety. What? We have a random. Yes. Thank you. And it's the entire API description, so I could swap this out with maybe not a random one, but I want to see what's trending. Okay? Oh, maybe not, because look, it's not just a single image anymore. It knows it. So what is it? Well, data in this case is an array of GIFs. So what I'll do is I'll go here and map over it. Haha. GIF response dot data dot map, and I'll get a GIF here, and I will do that. Always use keys, my friends. GIF dot, we will use the ID as the key. We will switch the alt text for something more meaningful, the slug perhaps. And here, instead of GIF response, I'll do GIF. Data doesn't exist, but OK, images does. Everything's satisfied, and what we'll have now is an array. Look at that. We could code an entire UI without ever leaving the editor. And again, we could just swap this out with use trending stickers. I don't know. Stickers are cool, I guess. Save. And just like that, we have spooky Frankenstein. Absolutely incredible. So let's land this plane. That was just a quick demo of how we're able to achieve, even with REST, end-to-end type safety in a GraphQL world using tooling. Now, I think the greatest stat I'd like to share with you is before we kind of knew the potential of this, we planned a feature, right? And this feature, we planned like a couple days for it. Because of the code generator, we were able to get this done in minutes, because we didn't spend time guessing, checking it in the browser, going back, checking it. We just coded according to our editor. We just tab, enter, and we had a UI. And with that, let's talk takeaways. Number one, types I hope I've convinced you today that types are not all evil. Yes, there are more complex concepts. Yes, there's extra syntax. But in the long run, it can build apps that you're confident are up to date. You have no problem refactoring or deleting code. It can lead to more concise expressions of your product. Number two, tests are amazing. I didn't get to talk about them, but Restful React, thanks to my brilliant coworker Fabien and team at Contiamo, has an extensive test suite, especially the code generator, And so we're able to know that it behaves exactly as we expect it to. And if it doesn't, we just add a test and fix against the test, and it continues to go. I'd encourage you, especially Kent Dodds is here, testingjavascript.com. Look at there he is, I think, or someone really likes him. But testing JavaScript is great to make sure your app behaves the way it expects, and we certainly enjoy testing. The last 2 points are a little bit philosophical, but that's just because I believe life's more than tech. Controversial, I know. Nothing really is impossible, potentially. If you're a software engineer, you can do so much with code. Like, working with imperative DOM APIs was not really comfortable, and so React exists, and it has taken the world by storm. There's another problem of doing multiple requests and things, and so GraphQL exists. If there's a common pain point you probably have the capacity to solve it. And I'd encourage you to get creative with your solutions, because guess what? When JSX came out for React, it was not well received, right? Like, I think most of us in this room, I certainly was like, why? And so eventually, though, the value was shown, and so I'd encourage creativity, solving real problems, while not talking about status codes and things. I believe these points can ultimately create better developer experiences, user experiences, software, and I genuinely believe these can benefit the world around us. Hey, thank you so much for listening. I really appreciate you making the time.